All right, so molybdenum has, we're going to put this with sulfur. Molybdenum has 3 different oxidation numbers. So we can't name these compounds simply molybdenum. You have to name them in a way that tells you which kind of molybdenum we're using. Okay? So I've got molybdenum, which is a symbol MO, with a 6 plus. I've got molybdenum with a 4 plus. And I've got molybdenum with a 3 plus. Okay? If I'm putting it with sulfur, sulfur we said has a 2 negative charge. Okay? So we got a 6 plus and a 2 negative. And to figure out the charges, we need to have this math problem here equals 0. So what coefficients do I put here and here? 1 and 3. That'll give us a 0. We don't really need the coefficient 1 in front of molybdenum, but we do need the 3 in front of sulfur. So this formula is MO S sub 3. And the name of this compound is named molybdenum 6 sulfide. Okay? Six is a Roman numeral, and there's no space between the parentheses in the name. Okay? Molybdenum 6 sulfide. Okay?
So if you're using like one of the oxidation numbers, when there's multiple ones, you got to name which one it is.
If it's a metal with more than one positive oxidation number, you have to use the Roman numeral. So in this case, we've got a 4 plus and a 2 negative. Okay? And we want that to equal 0. This is where we're figuring out the charges. This is how we're going to figure out the formula itself. Okay? So how many of these molybdenums do I need? 1. How many of these sulfurs am I going to need? 2. So this can be 1 and this has to be 2. And so this formula is MO S sub 2. And the name of this compound is molybdenum 4. Sulfide. And be careful. Roman numerals can be tricky. Be sure about your Roman numerals. 6 is VI, 4 is IV. Okay? Let's do this last one here. We've got a molybdenum with a 3 plus charge. Got a sulfur with a 2 negative charge. We need coefficients that will give us a charge on the compound we finish with of a 0. What prefixes, or coefficients do I need here? A 2 and a 3. Therefore, we have to have a 2 in front of the particle with a 3 plus charge and a 3 in front of the particle with a 2 negative charge. Okay? When we put them together, subscripts mean they're bonded together. So we bond them together by using subscripts, or that's how we communicate it. MO sub 2, S then sub 3, and we'll call this compound molybdenum 3, Roman numeral 3, sulfide. Okay? Does that make sense? All right, so let's take a compound. Gracious. Okay. Because it has a 3 plus charge on it. The Roman numeral 3 doesn't tell me the subscripts. Everybody listening? You need to know this. This is the biggest mistake students make on naming compounds, at least these kind of compounds. The Roman numeral has nothing to do with the subscripts in the formula. The Roman numeral tells you the charge on the metal ion. Got that? Can I move it now and go to something else? I'm playing with you. I'm sorry. I'm sorry. Okay, good. All right, let's do one where I give you the name and we write the formula, okay? So let's say we have 10, 4, chloride. 10, 4, chloride. Anybody ever heard of 10, 4 before?
Yep.
What's that mean?
Okay.
Or affirmative, yeah. Okay. All right, so 10, 4 then. 10 has the symbol SN. Okay. And what charge number then am I going to assign to 10? 4 plus, because the Roman numeral, that's what it means. It means that's the charge. Okay? Chlorine. What kind of charge do I assign to chlorine? Michael, need to sit up. Follow along here. -1. It has to be a negative number. So we have a 4 plus charge on the 10. Got a 1 negative charge on the chlorine. We need coefficients such that this equation equals 0. What we want is to have a compound that has a neutral charge. What I'm doing here is calculating the charges to get a neutral compound. So what coefficients do I need to work this out?
1 and 4.
A 1 and a 4. Okay, so I only need one of these, but I need 4 of these. To show they're bonded together then, I use SN and then Cl with a subscript 4 to show those are bonded together. How are we doing?
Great. Not great.
Not great?
No.
Pretty good? Kind of, sort of? No? All right. I want you to again do the first two in the two different columns here in class. Once everybody's finished the first 4, all right, 2 in each column, then we'll go back over those. But if you can get more than those first 4 done, do it, because you're going to do it as homework anyway. Okay? No, this is due tomorrow. The only worksheet that's due Monday at this point, yeah, is the one that the people who were out yesterday got today. Yeah.
I think you made a mistake on this, because on the formula writing for binary ionic compounds on the back of that worksheet.
On the last one?
Yeah. The third to last one says cadmium.
Oh, it's cadmium, yeah.
It's cadmium.
Yep, you're right. That's supposed to be an M. You're absolutely right. Thank you. So let's fix that right now.
Oh, hold on, Doc. You said do just the first four already.
Nope.
Well, do the first 4 for right now, but you're going to end up doing all of them anyway. You might as well work ahead until everybody's done.
Okay.
All right, who is still working on the first 4? Okay.